So this will be the end result of this effect, and we'll start with Houdini in a second. But first I would like to show you that really what we're going to be creating in Houdini is just a couple of layers. So this will be our first layer, and this is how the render looks like straight out of Houdini, and this will be the second layer. So after we split up all of the AOVs, and we won't have only just a couple of AOVs, but after we split everything up and we do some look dev and refining and adding glows, we'll end up with something like this. So we can clearly see a huge difference. Like in all of our other courses, a lot of the look development is really carried by what we do in Nuke, and this effect is no different. So we'll see how we can actually make everything look cool when we get to the Nuke part, but for now, let's start by creating these two renders in Houdini, and we'll start with the first main layer, which is this render here, and really this is just created with a noise. So both of these are not a simulation, this layer as well. Nothing is simulated here and neither here, but they do use a slightly different setup. So let's go in Houdini and we'll just create a new geometry container, start from scratch, and we can name this one effects. We can step inside and let's start with a circle, and let's place this on the ZX plane, and we'll make this slightly bigger. Let's use a uniform scale of 25. In this case, the scale doesn't really matter because again, we are not doing a simulation, so that's where scale would make a difference, but it's just going to be easier for us to dial in some settings and also create a camera with a higher uniform scale for the circle. We can also increase the divisions here so it's nice and round. Maybe we can set the divisions here to 100, and then all we have to do is just start with a scatter, and let's go ahead and disable relax iterations. Let's maybe just increase the total count, and we'll also disable the max point limit, and this will be the base start of our points. Let's also press D, go to the background here and set this to a dark background so we can see this better. And let's start by dropping down an attribute VOP and start working on the setups. So we'll base this entire first main layer on a noise. So let's rename this attribute VOP here to set noise or something like this. We can also, maybe we can color this, let's do an orange here for our attribute VOPs. We'll step inside, and if we were to just generate a noise from the position, we'll use a turbulent noise and we'll plug this in the CD. Let's set this to a simplex noise, and we want to use 1D signature because we just want to change really the color of the points. And let's also use a fit range after this so we better control what's happening. Maybe we'll decrease the source min and the source max. And maybe we can also go ahead and let's decrease the frequencies on all axes. So the problem is that even though this noise might be decent, the problem is that we can't really animate this going outwards. And this is a point where I got stuck in the past. And oftentimes I try to create something like a magical effect, but I didn't really need a simulation. I wanted something very simple, but I wanted the noise to animate outwards from the center of the object or the scene. So if we play around with the offset on X, Y, and Z, we can see that we can make the noise go in either direction here on X, Y, or Z, but we can't really make it go from the center. And this is where the two polar node comes into play. So if we drop down two polar, this two polar node will convert our XYZ coordinates from Cartesian coordinates to polar coordinates. So if I plug the position inside the pose over here, now our XYZ will become U, V, and radius. And if I were to create a vector from these new coordinates, so if let's drop down a float to vector, and we'll plug the U in the first one, V in the second one, radius in the third one. And now if I were to use this as our position for the turbulent noise, let's plug this inside the position. We don't get what we want right away, and this is because we have to change our value slightly, but we can see if I were to increase the frequency, we kind of get what we want. And now if we play around with the offset on either of our X, Y, and Z coordinates, which are now U, V, and radius, this is what happens. So if I increase this, we can kind of see something animating in a certain direction. And if I play around with our third one, which is the radius, now we can see that the noise is animating outward. So this is exactly what we want. And the reason we have this stretched pattern on our noise is because we have to fit the radius, which is our third value. So if we use a fit range, in order to get the noise that kind of looks like a regular noise, we have to make sure that our radius, our max radius over here, is the same radius as we have for our circle, which in this case is 25. So if I set the source max here from 0 to 25, now we get a noise that looks a little bit more familiar. So if I go back to our turbulent noise and I increase the frequency, we can see that this is the pattern that we get. So we can still play around with the frequency on our separate coordinates. So for example, if I wanted to stretch this on the radius, which is the value that goes outwards, I can just increase or decrease the third value over here, and we can see the different results that we get. So I can maybe increase the frequency and I can decrease the third value here. And the best part about this again is that we can animate the offset. So if I increase the third value here in the offset, we see this noise pattern is moving outwards, and we can also push this inwards. So this is the most important part here in this setup, to make this noise be sort of mapped in this kind of radial way. So let's maybe arrange these nodes slightly. And the coolest part here is that this will also run on a sphere type of geometry. So if I just go up and if I were to drop down a sphere, and let's reset the radius and also make this a scale of 25. Let's set this to polygon and we'll just increase the frequency. I want to scatter points inside this as well. So instead of a regular scatter, let's use a points from volume, and maybe we'll increase the point separation so we don't have that many. Let's give this a second. Let's set this to maybe 0.5 or so. So we have 500,000 points, should be good. We'll increase the jitter seed and scale, and then if I plug this in our set noise, we can see that our noise will still work. So if I go inside, I can still go to our turbulent noise and I can increase the third value here, and we will have this noise pattern moving outwards from the center of our sphere, which is really great. And if we just look at this animation as I'm dialing up the values here, we can clearly kind of start to see the potential for different kinds of effects. In the past, I've managed to create a pretty stylized explosion using this setup as a base. So there's really a lot of potential here. Now let's go back to our effect. So I'll just plug back my circle with the scatter, get rid of the sphere, and this is really the first part of this effect. We can now simply right click our turbulent noise. Let's create input parameters, and also the same for our fit range node. So we can go up and now we can play around with our noise and we can animate the offset. We'll make this go inwards, so we can just set the offset here. Let's use $T, and let's multiply this with -0.5 or something like this, and let's take a look at the speed. Seems to be all right. Maybe we can make this go a little bit faster. I'm just going to use my scroll wheel to decrease the value here. So let's maybe go to around -1. So this looks pretty good. And from here, really, it's just a matter of twisting our points in this circular direction. So from here, let's do a blast and let's get rid of all of our dark points. So let's go ahead and set the expression here to be CD greater than 0. We'll set the group type to points and let's delete non-selected. So now we can see with this blast node, we get rid of all of the completely dark points, and we are not going to render those. So it's worth just optimizing things along the way. And maybe we can also play around with the minimum threshold here for our fit range. We'll probably come back to these settings, but from here we can also map our black and white colors to an actual color. So we can just use a color node from here and let's set the color type here, ramp from attribute. We'll base this on our original color, so our CD, but we are just going to remap the values here. We'll go from black and let's go to maybe something like kind of like a pink color, maybe towards violet, and let's make sure that we do have enough value, and we always want to desaturate the highest value color that we set for our particles in order to have that really bright, additive and emissive look. So I'm just going to introduce a little bit of saturation here, make sure we have some white in our color. And we can also play around with the ranges here, but we can decrease this to maybe 0.7 or something like this. Should be cool. And something I usually like to do is, in order to preview what we are actually going to render later, is if I drop down an attribute wrangle, I like to use a couple of expressions here. And the first one is I just want to multiply the color by a factor. So we'll say here at CD multiply is equal, and we'll just create a channel, so CH, and in between parentheses and quotation marks let's do CD mult or something like this. Let's maybe zoom in here. So if we create this channel, I'll set this back to 1, and now as I increase this, we can kind of start to see this additive color that I was talking about earlier. So let's set this maybe to a value of 10, and also we can play around with the alpha, and both of these lines will just be for preview purposes. Let's also set at alpha, and we'll just set this to another channel here. Let's do alpha mult and end quote. Let's create the channel, and we can set the alpha to a lower value. So if we decrease this, we can kind of get a feel again of how these particles will look rendered. So if I were to enable and disable this, this is what this wrangle will do. So let's rename this one to preview PRT. We can make this pale yellow, and if I just increase the total count for now, let's maybe add another 0, we can really start to get a cool feeling of what we are creating. Let's maybe set this back to the previous value while we are working on the rest of our setup. And after the color here, let's disconnect this node for now. We'll add this back later. After the color, let's use another attribute VOP, and let's rename this one to twist. And we'll also make this one orange. So what we want to do is simply rotate all of our points, but then we can just scale the rotation based on the distance towards the center of our scene. So if I plug the position back into the position, we can use a rotate nodes. So this will give us a matrix. Now we don't have to worry about all of this stuff over here. This will probably be covered in a separate lesson or course. What we are interested here is that we have an angle and we have an axis. So if I want the particles to spin in this direction over here, the axis should be the y direction. So I'll set the axis to 0, 1, and 0, and then with the angle we can control the rotation. And to introduce this matrix on our position, we have to use a multiply. So usually when we are dealing with vectors, we use add or subtract, but in the case for matrices, we have to use multiply instead. So we'll multiply this with our matrix, and we can see now if we go back here, we can control the angle, and all we have to do is just scale this value by our distance. So from our position, we'll generate a distance. We want to use a feet range because we know our circle has a radius of 25, so the max distance here will be 25, and we can just plug this directly inside the angle, and we can now further control this overall strength with our destination max. So we can see that this is the result that we want. We can also introduce some ramps if we want, but in this case, we just want a straight increasing rotation like this. So we'll just promote the destination max. And now at the top level, we'll have this option here. We can control how much twist we want. And if we look at our animation now, we can see that we are almost there with our first layer. And one more thing that we can add over here, I kind of want to add some thickness. I kind of want to add a little bit of extrusion to our particles. And maybe I'll increase this. Let's add another 0 here. And this should play fairly fast, running at around 13-14 frames, which is decent. So let's go ahead, and we have this black and white value from our points, and after we run our blast node, maybe we can do this after our color. So before our twist, let's use another attribute VOP, and let's rename this one to extrude, and we can see how very easily we can just layer a bunch of deformation and noises and achieve a pretty complex effect. So this is usually my go-to method to achieve any kind of magical effect especially. So let's maybe also make this one orange, and if we step inside Let's actually do this before our color because we need our black and white values intact. So I'll just place this extrude before our color, and let's step inside. So we have this black and white value, and this really is a value that goes from 0 to 1. So when this color is 1, meaning more white, I want to push the particles straight up by this amount. So if we plug the position back inside the position, we can drop down and add, and we'll use a constant here. Let's set this to a 3 float, and we want to push the particles straight up, so we'll use 0, 1, and 0. So if I plug this inside the add, all of our points will be displaced upwards by 1 unit, and we can just scale this based on our color. So if we grab our color, let's use a vector to float and just grab one of the values. We can use either of these outputs here. We can just use the first one. So we'll just multiply our vector by our color, and this is the result that we have. And we can further control the overall scale. If we just promote our third input in this multiply, we can rename this label here to something like global. So if we go up, we can just control the amount of extrusion that we want. So we just introduce a little bit of thickness, like I said, for our particles. Then we can run our color node, our twist, and we have this result. So this is already looking pretty cool, and we are close to finished with our first layer. Now, what I did in the original example is I just layered on top of this set of points, another set of points. So from our set noise over here with our color, let's maybe drag these to the side, and I can just duplicate all of these nodes by holding Alt, and let's merge this back into one chain. And if I set this color node now, we can just make this one, let's maybe just change the hue here to something like a blue. We can simply go to our noise values here, and we can play around with the offset. We can just change the pattern by changing either of these offsets, and we can see how very easily we can just introduce some variation here. And for our second layer here, I also maybe want less particles overall, so I can just increase the minimum value here in our fit range, so we end up with something like this. All right, so if we run this for a few seconds, we can also preview this with our attribute wrangle here to get a better idea. So this is the result that we end up with. And really the final thing that we have to set up here is the particle scale. And I also want to base this on the overall intensity of our color. So we can go to our twist. Let's use another attribute VOP, and let's rename this one to set P scale, and we'll let's color this orange, dive inside. We'll grab our color again, and we'll split this up to a float value. And if I plug this in the CD, we can preview this now. So we had the same values that we had originally. So we can just use this to base our particle scale on. So from this value output here, we'll do a bind export. We'll export this to a P scale, and let's also use a multiply before this, promote the second input, and this will be, let's use P scale global or something like this as the label. And let's disconnect the CD connection here. We'll go up, and we'll need a very low particle scale, so something like 0.01, and we can kind of preview this. We can go to our attribute wrangle, and if I set the properties here to lit spheres, we can kind of get an idea. Now with our attribute wrangle, this will be a lot slower, so let's just go to our VOP instead, and maybe I can increase the global P scale, and we can kind of see what's happening. Now we can probably introduce a ramp here as well to kind of control this fading, and let's go back inside and let's run this to, so the vector to float, let's use a ramp parameter before our multiply, set this to a spline ramp. And if we go up, let's reset the ramp, and let's add just one more point over here, so it's not this sharp fading towards 0, but rather we try to slow down this scaling over our value, and we'll set this to a B-spline. So we end up with something like this, and maybe I'll just decrease the P-scale. Now the P-scale will also control directly in Solaris when we do our rendering. So for now, let's just maybe use a base value of something like 0.02, and we'll set this back to points. And I think we pretty much have everything we need. Maybe we can set this to pixels instead. Let's play this for a few seconds. Probably this might be too fast. We can just go to our scatter, remove some points here so we can preview this. And I do believe that this might be a little bit too fast. So let's go to our set noise here, and we can just increase this value to maybe negative 0.6, and we can just copy this value to our second layer as well. And let's maybe take a look now. So I think this feels slightly better. And with this, we have pretty much everything we need for our first layer. And with the next lesson, we can start working on our secondary layer. So I will see you there. So now for our second layer, we can take care of the additional points that move along with our noise. And we will need a different setup for this. So for example, if I were to just decrease the scatter amount, let's maybe just set this back to points. And let's say that we want to use the same method that we have over here with the noise, and I just were to lower this. We can see that when we are working with a much lower count, we lose this seamless effect of that's kind of making the particles appear as they are moving. So really what we are doing here is we are offsetting the noise. So we are just making the noise swim across our points, but really not actually moving the points. And when we have a lower count, we will actually have to move them. So we will have to change their position. So let's maybe just set this back to 1000 or something like this. We'll keep the display to points, and we'll start our setup for the second layer over here. Now we know that we want our points. If we think about this for a second, we want a point to start on the outer rim, so on the edge of this circle, and we simply want this to travel towards the center, and then we can layer the same kind of twist displacement that we have over here. We can just layer this on top as well. So similarly to how we start with a noise that travels towards the center, we will just have our points start from this edge of our circle and just move them towards the center. So let's maybe just duplicate the circle and our scatter over here. And for our circle, we don't need to fill this entire space. We just need the edge. So we'll set the arc type here to open arc. We'll run our scatter, but we can probably use way less points for this. Maybe something like 5000. We'll probably change this later. So this is really the starting position of our points. And now to move them towards the center over time, let's do an attribute VOP. Let's rename this one to move PTS, color this orange, and we'll step inside. So we just want to add a vector that points towards the center of the scene to our current position. Let's plug the P back into P, and to get this vector that points towards the center, we can just grab our position and run a normalize over this. So if we add this to our original position, we can see that we are slightly displacing the points. So if I were to turn this on and off, we can see this is the result. And the way this works, if we just normalize the position as it is, this is the same as usually when we want to create a direction, we can subtract two vectors, and this will give us the direction from one position to the other. So for example, if I were to do a subtract over here and set this to a constant of 3 floats here that points towards the center, we are subtracting the position of the points from the center position, and this is exactly what we are getting by default. So we can see that if we were to bypass this, we just get the same result. And this is because by default all of the positions are measured from the center of our scene. Now, if we wanted to customize this direction a little bit, we can see that if I were to play around with this 0, 0, 0 coordinate, so for example, if I were to maybe set this to -3 or something like this, let's maybe just increase one of these values. We can kind of see that we get a different result over here. Now we are normalizing this, so it's not going to move that much. But for example, if I were to maybe increase the Y value over here, we can kind of see that we are offsetting the position. But we just need these points to move towards the center, so we can just keep this position straight into the normalize, and then we are adding this on our own position. So now from here, we can see that this operation by default, this vector will make our particles go outwards, and we want the opposite direction. So let's do a negate, which is just multiplying this by -1. So now they will go towards the center, and we can just scale this vector now. So if we do a multiply, and if I were to promote the second input here to a constant for now, we can see that as I start to increase this value, we can go above 1. So as I start to increase this, we can just slowly push our particles towards the center here. And since our circle has a radius of 25, when we reach this 25 value here in our multiply, all of our points will be right in the center. So instead of setting this value here ourselves, we can just use the time instead. So I'm just going to duplicate this global node and maybe close off this first window for now. And from here, let's link this to our frame. So if I just plug the frame into our multiply and go back to the beginning of our timeline, we should see that each frame, as I move forward using my arrow keys, we are just incrementing our vector by 1. And when we reach frame 25, this is where all of our points will be right in the center. But now when we go over 25, they will go in the opposite direction. So what we want to do from here is when they reach this value of 25, I want to reset this value back to 0 and keep cycling this 0 to 25 value over our frame. And this is where the modulo function comes into play. And I have a separate lesson in the Practical VOP series going more in depth about the modulo function, and we used the modulo in that case to create a cycling animation of points moving across a curve. And we are essentially doing the same thing over here, only instead of making the points follow a curve, we are just making them move towards the center. So from our frame, if we do a modulo function, we want this cycle to repeat every 25 frames. So I'll set the divisor here to 25. So now we can see that when our frames reach 25, this animation will now repeat. So if I just play the animation, we can see this is the result. And we will be able to control the speed if we do a multiply before the modulo and over our frame. If I were to promote this to a constant for now, we'll promote this to a parameter in a second. But for example, if I want to slow things down, maybe to 50%, I'll set this to 0.5. So now our points are moving twice as slow, but they will still repeat when they reach the center. So now really all we have to do is offset their position along this path. So really this value that we are plugging inside our multiply, we can just offset this value with a random number per point from 0 to 25, which is our frame range essentially. So let's first create a random value. We can grab our ptnum. We'll do a random and we want to fit the 0 to 1 value. So let's do a fit range. We'll go from 0 to 1 to 0 and 25. So if we add this before our modulo, let's drop down and add, and let's place this here. We can see now that all of our points are offset. Let's maybe press D and make our points maybe smaller. And now we have the animation that we want. All of the points are randomly offset as far as their position is concerned, and they are repeating every time they reach the center. They will go back to the edge of our circle, and this is how we can kind of get this animation that looks really like a particle simulation, but everything is linked to our frame number and it's animated procedurally. So this is exactly what we are looking for, and really we can layer a lot of variation on top of this movement. But one thing that I would like to do for now is just randomize their speed. So over here where we are introducing this first multiply with a this overall control, let's maybe get rid of our constant for now and just promote the second input to a parameter, and this will be our global speed. And I would like a minimum and maximum speed per individual point. Now we can use a random value generated from our ptnum, but I found that this creates kind of a weird result where we can clearly see a cycle repeating. So for example, if I were to just grab this random value and plug this in our multiply, and let's maybe just go up and set an initial global speed here of 0.5. If we look at this, we can kind of see it kind of works, but we can see over here that there is a set of points based on the point number that are kind of starting with the same speed. So we have this delimitation here. Maybe if I set this to pixel display and increase the scatter amount, we can see this better. So this is the problem that's happening. And I found that a better solution is to use a noise instead of the random function. So for our noise, I would like to base this on the position on our points, but not their world position, rather their starting position, which we have over here. So we can drop down a rest position and we can base the noise on this rest position. So if we go back in our attribute VOP, let's disconnect our random input in our multiply. We'll do a bind to bring in our rest attribute, set this to a 3 float, and we will generate a turbulent noise pattern. And we can also do a fit range here, and we want to use a simplex noise. If I plug this in our color, we can visualize this value. So let's plug this in the CD for now, and we can kind of see this stretched pattern here. We can go to the turbulent noise, and let's increase the frequency. We want a nice and random value. Maybe also introduce more roughness, and we can probably decrease the source. Let's normalize this noise, so the values by default go from around -0.5 to +5, or rather +0.5. So now this is the value that I want to use for our multiply. So I'll disconnect this from our color, drag this over here while holding shift, and plug this in our multiply instead. So currently we have the minimum and maximum speed for the points to 0 and 1. We can promote these as well to the top level, and if we go up, let's say that the minimum speed will be something like 0.3 and the maximum speed we can keep at 0.1. So now we can see that some particles will move faster towards the center than others, and we can control the global speed. And now we can just simply layer, like I said earlier, the same kind of displacement with this twist. I can grab this attribute VOP here with the twist, hold Ctrl, Shift and Alt and drag this over, and this will create a reference copy. So now these values are linked and we have the same kind of setup that we had earlier. So if I plug this inside this twist, let's maybe move everything down and preview the result. We can kind of see it's not noticeable right away, but if I start to play the animation, we can see our points also spinning. And maybe now we can go ahead and let's scatter less points and maybe also move back to our point display. And this is the result that we have. And we can kind of layer this. If I press W on our attribute VOP here, we can kind of preview these both together, and we can see this with our noise pattern as well. So we can decide on the speed while previewing these, and I think the speed that I currently have is pretty good. I'm looking at how fast our noise is evolving on our first layer, and probably we can maybe make these a little bit slower, so I'll just decrease the global speed. So something like this seems to be working fine. And this is really it. This is the main part of our setup for the second layer. From here we can just randomize their color and maybe their p-scale. So let's drop down an attribute VOP for the color here, and this will be our set CD attribute VOP. Make this orange, step inside, and what I like to do here is let's maybe start with the same setup that we had earlier. So actually I'll go up and go back inside this move PTS attribute VOP, and I want to grab this setup here with our rest and turbulent noise. Let's copy all of these nodes and let's go back here and paste them here. in our set CD attribute VOP. And this value here, if we plug this in the CD, we can see this. We can maybe get rid of the destination min and max value. Let's keep this at 0 and 1, and let's plug this inside a ramp parameter instead. This will be our color ramp. So if we go up, let's make some of these particles, we can make them blue, and the other particles, we can make them the same kind of pink color that we had earlier. So now our result looks something like this. And because we are basing this noise pattern on our rest attribute, we can see that the color will stick with our particles as well. And finally, we can also randomize the p-scale. So let's just do an attribute randomize for this, set this to p-scale. Let's maybe set a global scale here, start with a value of 0.1, and we can also preview this if we turn this to lit spheres, maybe increase this for maybe 0.15. And here we can just do a custom ramp, and we can fit the minimum value to maybe 0.3 or something like this. And here I like to use a B-spline ramp and set this to an exponential ramp. So only some of these points will have a full p-scale factor of 1, but most of them will be closer to the 0.3 value. So we just introduce some nice variation. We can also maybe plug this in our attribute wrangle here with the preview, so we can see them a little bit brighter, and this is the result that we have. So from here, I think we have pretty much everything we need from our setup. We have our base layer and our additional layer, and with the next lesson, we can jump into Solaris and start rendering these layers. So I will see you there. Now, before we jump in Solaris, I think it's worth creating our camera at the sub level, just because usually I do some tricks with parenting with camera, and it's just easier to handle at the sub level, and we'll just import the camera later in Solaris. Now, from our main setup over here, we have our main layer, so we can just do a null from here, so we can point to this. We'll do out main underscore PRT, and let's maybe just use pixel display, and we can also preview this with our attribute wrangle setup. And over here to the side, we'll have our out PRT, and we can just do here, let's do PRT add. And let's preview our main particles instead. From over here, we can go up, and I have the camera and the setup from the original example that I did, but we can just create a new one. So let's drop down a camera, or actually let's go in our viewport, and from an angle that looks something like this, we can just hold Control and click the camera icon here to drop a camera from the same viewing point in our viewport, and we can see that this is also locked. So whatever modifications we'll make will transfer to our camera. We'll go to the view tab here. Let's set this to full HD, and maybe we'll just decrease the focal length to 35, so it's a little bit wider lens. And what I did for this, we can sort of tilt this camera if we hold down Control and click drag to the right or left. We can also slightly tilt this on the sort of like the Z-axis of the camera, which I don't think it's something that a lot of Houdini users don't actually know, that you can do this with the camera by holding down Control. And really, I'll have to make a separate tutorial just for camera animation in Houdini, because I have a lot of interesting rigs for different use cases, so you can really create some advanced camera motion in Houdini if you're smart a bit about parenting and setting up some look-at constraints. But for now, let's say that this can be our starting angle, and we want to just create an orbiting animation. So the easiest way we can do this, if we drop down a null, we can parent our camera to this null, and we can just use the rotate values on our null to create this kind of orbiting animation. So we'll Alt and left click this rotate value for some initial coordinates that we set over here. Maybe we can do something like this. Now I'm not going to spend too much time because I've already rendered these layers, but I just want to give you an idea of how I set up the camera. So we can move to the end of our animation, and here we can just offset these values. Maybe I'll increase the Y value here and also tilt this more horizontally like so. So we end up with something like this, which again will be fine. If we shift click our rotate property over here, we can go to our animation graph and we can select all of our keyframes here, and let's make them linear, so we don't have this ease in and ease out, and we just have this constant animation on our camera. So let's say that something like this is fine, and we can start working on our Solaris setup. So let's hold down N and go over to Lobs, and this is where I had my previous setup. So it's a very simple setup. We can start by placing down a scene import first of all, and let's choose the camera preset. Let's place this here, and let's make sure that we are only grabbing now our second camera. So this is the one that we just created, cam 2. Let's hit accept pattern. We can also, something like I like to do here is flatten hierarchy. So let's also set this to the Solaris look dev that I have, so we can also see the scene graph. All right, and let's go back to our scene import. This can be our cam, and we can see we have this cam 2 over here. And let's go ahead and grab from our object level. We'll go back in our effects container here, and we'll grab our out main PRT. Let's copy this, go back over to Lobs, do a SOP import, and we'll bring this over here. Paste the SOP path. Here we have our particles. And for our path here, I'm just going to place this in a layer called effects. So /effects. Here we have it. It's just containing our points, and we can just merge this with our camera. So we have something like this. We can look through our cam 2, and we have our particles. And from here, we can create our material. So we'll do a material library. Let's step inside. Let's do a Karma material builder. Let's rename this one to PRT, and we'll use the same for both of the layers. We'll go inside, get rid of these two nodes and the inputs here as well. And for our material, we'll do the material that we always do for emissive particles. So I'll set the base value here for the color to 0. Specular, we don't need this, 0. Roughness, 0. Coat, we don't need anything else. We just need our emission. I'll set this to, let's start with a value of 10. And for the emission color, we'll bring the color that we already have on our points. So let's do a USD primvar reader. And the var name here in Solaris will be display color with capital C. So make sure you spell it like this. Set the signature to 3 floats, and let's plug this in our emission and in our emission color. So now we can go up. Let's go up again. Let's autofill materials, and we can assign this to geometry. We'll do here, let's do /effects. And now we have the material on our particles. And we can do a Karma render settings node. Let's point this to our camera, set this to full HD. Here you can specify the path that you want. And I render the original layers with Karma XPU. So set this to XPU. Probably we can play around with the path trace samples in a second, but in the limits tab, because we have super high values on our emission, I like to bump this up to maybe 25, and the other settings I'll leave as they are. So if we do a test render from here, let's press Shift R, and let's set this to XPU, and let's also press D and get rid of our background here, or rather set this to dark. All right, so this is the default that we have. We can see that our material is working. And let's add a Karma fog box here as well. So let's drop this before our Karma render settings, and we'll just increase the uniform scale here. Let's maybe bump this up. Maybe we can go all the way up to 50. Let's make sure that this encapsulates our particles here. Let's maybe just go to 100, and maybe I'll grab the handles here with Shift and just readjust this so it's not really this further out our area of rendering here. So something like this looks to be all right. If we go back and do a test render with this, by default the density is way too high. So let's set the density maybe to try 0.5. And the reason we are getting this white flat color is because the emissive material on our particles isn't really interacting with our fog box, and we want to render the particles as light geometry. So after the material library here on our particles, and let's also rename this one, I can rename this SOP import node to main PRT. So after we assign the material here, if we do a render geometry settings, let's run this over our effects layer. We'll go all the way down here, and all of this is covered more in depth in the Intro to Solaris course that's available for free on voxeye.com, so check that out. And here we want to select, if we go all the way down to light, we'll enable the street as a light source and we'll set this option to yes. So now if we do a test render, we still are not going to get exactly what we want, and this is because by default we are rendering with a base headlight display, and to get around this issue we can just append a simple light here and I'll set the intensity to 0. So now really the only lights in our scene will be registered from our particles. So finally, if we do another test render, we get the result that we want, and now our light that's coming off of our particles is actually interacting with the fog box. And we can see this if I were to go to the image output here, and we'll need to set up the AOVs anyway. We can go to, let's close the beauty, and we can turn on our volume here. Let's turn on combined volume, and for our lights and emission, our particles will now be in the visible lights AOV. So now we can go to the AOVs, and here we have our combined volume, and we also have our visible lights. And we can see that our visible lights are obscured, especially in the back. We have this feeling of depth in our scene, and this is because of the Karma fog box. We can see that in the back our particles are a little bit darker. So if I were to disable this, we can kind of see what this Karma fog box will do for us. So if we go back to our beauty display, maybe we can increase the density back. I can increase this value, but let's also turn the shadow density. I don't want the fog box to really obscure the particles that much, so I'll just set this to 0 instead. And now we can kind of see all of this fog. And we can also increase the scattering phase. If we increase this value, this will skew the brightness of our fog box, or rather the light bounces in the fog box towards the actual emissive object. So for example, if I were to turn this all the way close to 1, we can kind of see now, especially if I just were to preview the combined volume pass, we can see that we have this hazy glow right around our particles, and this is because of the scattering phase right here. Now I don't necessarily want this. There's certainly a use case for this, but what I want in this case is maybe the opposite effect. I want the scattering phase to be brighter further away from the actual emissive object. So in this case, I might actually set this to a negative value. Or maybe I can just leave this close to 0. And I think this will be fine in this case. Let's preview our beauty. And if I want the scene to be overall brighter, I can increase the emission strength in our material, but let's first just increase the total particle count, because we will need way more particles than this. And when we increase the count, we will have an additive effect, so it will make our scene overall brighter either way. So let's maybe go back to our object level, and inside our container, we'll go to our scatter here, and we currently have, we can see we end up with around 130,000, so we need at least 10 times this amount. We can add another 0 here, and probably we can even bump this up. Let's try a factor of 5 here, so we end up, let's see, around 6 million. I think probably for something like this to look good and smooth, we might be looking at around 10 million. So let's maybe bump this up even more. So now we end up with roughly 12 million. Now the cool part is that Solaris can handle this fairly well. So if we go back to Lobs tab, we can see that even if I were to just preview some frames, it's loading up rather fast. Now, if I were to preview this render now, our P scale will need some adjusting. So if I do a render, we can see it's taking a second to initialize, but then it's working fine. We can see overall that the scene is brighter, which I mentioned earlier. When we increase the particle count, this will light up the scene more. But now we have to reduce our particle scale. And like I mentioned in an earlier lesson, we can do this directly inside Solaris. So here we can just drop down an attribute wrangle. We can run this over the actual points object from our effects layer. So here we'll do effects. We'll point this to our points 0 object. And when we are in the Solaris context and iterating over multiple points at the same time, we have to turn on this run on elements of array attributes. And the p-scale attribute in Solaris is width. So here we'll do at width multiplies equal, and we'll create a channel. Let's do p-scale adjust and do a semicolon here. Let's create this channel, and if I were to multiply this with 0.1, we will now have 10% of their original p-scale size. So if I do a render now, we should see that our particle size is a lot smaller. So now our particles look really smooth, and we have a much better result. Now still, I will want the scene overall to be brighter, so we can still go to our material here and we can adjust our emission. Let's bump this up to 35, and whatever value we are using here, we should use in the limit as well. So we'll go back to that value in a second, but this is the result that we have. We can still play around maybe with our particle scale. Maybe we can bump this up back a little bit to 0.15. We can see we do end up with a little bit of noise. Now, some of this is intentional. I don't want a completely smooth result. I kind of want a little bit of separation. I kind of want this feeling that it's made up of a lot of points. And this is an intentional decision. We can kind of try to use a denoiser and maybe motion blur in this case. So if we wanted to smear the particles in this direction, we could create a velocity that goes in the same direction as our noise, and then turn on motion blur, so that will smooth things out. We are going to smooth things out in Nuke regardless, but that's something that you can do directly inside Houdini. And also sometimes the denoiser, this optics denoiser, can give you some pretty cool results when you are rendering particles. So if I turn this on, it's actually working quite well in this case, and it's fairly fast as well. So if I just preview a few frames, maybe we can do Control B, preview this in full screen, we can see that it's actually doing a fairly decent job. But over here, I mean, some of these areas over here are kind of blocky a little bit, and we still end up with this noise in the front. So in this case, I would rather do the denoising in Nuke, which we will do in the Nuke part. So let's maybe just ignore the denoising for now, set this to no denoiser. And for the path trace samples, we can probably bump this up to 256 or maybe even 512. This will be up to you if you want to render this on your own as well. I think in the original render, I used around 256. And really, we have everything we need from here. We can do a ROP, or rather a USD render ROP, set this to Karma XPU, render the entire frame range, and you can render to disk and have this first layer ready. And for the second layer, I use the exact same setup. So I can really just duplicate this entire chain, drag this over here to the right, and we will just replace the main PRT. If we go to the object level, we can grab the out PRT add. So this layer, we can grab this and paste this over here. And everything else will update as well. Probably in our attribute wrangle with the p-scale adjust, we don't really need to scale the particle scale down by that much, so I'll just increase this value. And here the original render, I rendered with this Karma fog box as well. So if we do a test render, we can see that this is the result that we get. So we still have our combined volume and our visible lights, but I didn't end up using this combined volume pass at all. So really here I just needed the particles, so we can go ahead and just get rid of this Karma Fog box and just render this as it is with just the particles. Now they appear white, and this is because it has super high emission values, but really if we go to the correction toolbar, what we are going to end up with is something more like this. So if I lower this value here in the viewport, we can kind of see our original colors back. And probably these are too big, so I can just adjust the p-scale here, make it something more like this. So this is how you can set up this additional layer, and we are more or less ready to go with the rendering, but we can still add a couple of extra things. We can modify the color of the main layer just a little bit so it's brighter towards the center, and we'll want to set up some attributes on our points as well, which we can export as custom AOVs, which we can later use in Nuke for further control. So let's see how we can do that with the next lesson. So we can do the final adjustments for this main particle layer, and we will just like to alter the color. Let's go back to the object level, and for our main layer here, probably before our twist, let's do another attribute VOP, and this will be our, we can do CD adjust, and we'll also color this. Let's do orange and step inside. So what we want to do is grab the distance. Let's maybe set this to pixel display. And maybe while we are working on this, let's maybe just reduce the overall count to something lower, just so everything loads slightly faster. So we'll step inside, we'll grab the distance from our position, we'll measure it to the center of our scene, 0, 0, 0, and we would like to remap this. So let's do a fit range here. And if we plug this in the CD, we can see that our source max should be 25. And probably we can also use a ramp here. Let's use a ramp parameter, and let's set this to a spline ramp. And if we go up, we can reset our ramp, and now we can control these dark and bright areas. So what we want to do is first we can reverse this ramp, and we want to skew the brightness right towards the center. So we'll just move this point over here, and let's set this to a B-spline. And maybe we'll just move this point towards the center as well. And this value we would like to add on top of our color. So let's go back inside and let's duplicate this Vogue global node. We'll plug the CD back in the CD, and then on top of this we'll do an add and add the result of our ramp. Only we don't really want to brighten this up all the way to 1, so all the way to white. So we would like to further scale this down with a multiply here. Let's promote the second input, and with this value we can just brighten up the center. And we only want a bit, maybe like 20% or so. Let's do maybe 0.25. And we also want to darken the color towards the edges of the circle. So if we go back inside, we can use the same values here, but we'll use a different ramp. So let's do another ramp parameter, and we'll have to rename this one. Let's actually do ramp darken, and this will be ramp darken. Let's set this to a spline ramp as well. Plug this over here, and let's also preview this first in our color. If we go up, we'll reset our ramp, and let's do the same thing with the sort of the same values that we used earlier. We'll use another point here and set this to a B-spline, but what we are going to do with this value is just multiply this over what we have. So we can actually grab this ramp here, and this CD, before we do our add, let's do a multiply with our second ramp that we created, so the darken ramp, and then we run our add, and then we can plug this inside the CD. So if I were to enable and disable this, we can see the result that we get. And again, we would like to scale this darkness intensity. So what we can do here, we can't use a multiply, we'll have to use a fit range instead. And with our destination mean, if we increase this to 1, we can see that we decrease this intensity. So we can just promote the destination mean, we can go up, and we can also probably look through our camera. So now we have this input number 2 here. We should probably rename this one to, let's do brightness, and this destination mean can be, let's do darkness. All right, so if I go up, we have this brightness adjustment here, and then we have our darkness adjusting here as well. We can probably preview this better through our preview node over here. And if I were to enable and disable this CD adjust node, we can see the result that we get. So this is looking good. Maybe we can lower the brightness slightly. This is something that this overall adjustment is something that we can do pretty much in Nuke as well, either with some masks or some custom AOVs, but it's just faster and you have a bit more control if you do it directly in Houdini. So our render is good to go, but like I mentioned, we want to set up some extra AOVs as well. We can, for our points here, we can also add a rest, and we can export this rest attribute, and we'll add this to our scatter. Let's disconnect the second input. We'll run this rest right after our scatter before we do any of our displacement, and we can export this as a pass. And we'll also need a distance as well. We can export this so we can create some custom masks inside of Nuke. So we can do another attribute VOP after our scatter. Let's rename this one to set distance, and we can color this orange. And if we go inside, we can just measure a distance from the center world origin to our position, and we can just export this as it is. We don't have to use a fit range because we'll be able to remap the values directly inside of Nuke. So we can just do a bind export here and export this to a attribute called dist. You can name this whatever you want, but usually I like to use dist. So we have everything we need for this layer, and for our PRT add layer here, we can also export a custom pass. Let's maybe set this back to points. We can export a custom pass that's a random value per individual point. So if we do from here an attribute VOP, we can rename this one to set rand, and let's color this orange, and we can step inside, and we'll want to use the same setup with our turbulent noise. So actually let's go grab this from our move PTS. We want this setup over here with the rest, turbulent noise, and fit range. Let's copy these nodes, paste them over here. And again, if I were to plug this in the CD to visualize this, let's maybe remove the parameters for our destination min and max. So we want this to go from 0 to 1. We can see now that all of the points will have this random value from 0 to 1, and we just want to export this as an attribute as well. So we'll do a bind export. Let's remove the CD connection, and with this bind export we can just name this attribute rand. So now we have everything we need for this layer as well. If we go back to the LOPS tab, to Solaris, we can grab our main particles, and we can go to the AOVs here, and we want to go to the extra render vars, and we'll want to add our attributes as AOV. So for our main particles, we have our rest and our NA distance attributes, so dist. Let's first take care of our rest. So here we can give this AOV any name that we want. We can do something like rest underscore AOV or something like this. Any name will work. The format will be the format that you want to export this as, and since this is a tree float type, we should also export this as a tree float. So here let's look for float tree. This will be the format, and the data type is the data type that our attribute is in, and our rest attribute is also a float tree type. So let's set this to float. Let's go over here. We have float tree. Now the source name will be the name of our attribute, which is rest, and the source type will be primvar. And for the pixel filter, we can leave the default, and if we do a render now, we can go to our rest AOV, and we can see here we have the rest vector information stored on all of our points. And we can do the same thing for our distance, only some settings will need to be different. So if we hit plus, we can name this one dist underscore AOV. The format, we can export this as a float as well, and the data type has to be float here as well. So let's set this to float, and the source name will be the name of the attribute, which is dist, and the source type will be a primvar. So we can also do a render. We can preview our dist AOV, and we can see we have this increasing value from 0 to 1 all the way to 25, and we can also preview this gradient better. Let's maybe go back to our cam, and let's actually go back to the object level here and set this back on our scatter to the regular amount, which is with a multiplier of 10. So now we can go back into Solaris, so we can preview everything a little bit better. And if we preview now this AOV, here we have it, and if we lower the intensity, we can kind of see this gradient better. Again, we'll be able to remap these values in Nuke. And for our add particles, for our second layer, we want to do the same thing. We want to add attribute as the AOV. We'll go to our render vars, and here we set up a random attribute. So let's do rand underscore AOV. Format will be float, data type can be float as well, source name will be rand, and the source type will be primvar. And if we do a render, we can preview this over here, rand AOV. We are seeing this as red because we are only filling up the first channel in an RGB layers. So this is where this format comes into play. If I were to export this as a color 3F, we can see that now all of the RG and B channels are being filled with this rand value got from our attribute. So since we have all of the channels, we are exporting this as a white layer now. But in our case, we don't really need all the 3 channels. We just need 1 channel, so we can just set the format to float. But now we do have everything that we need. And if you've been following along, you can start your renders. And with the next lesson, we can dive into Nuke and start compositing. So I will see you there. Now we can get started with compositing. A couple of things before we get started. If I'm in the node view and I press S to go to the project properties, here I set the frame range to 1 to 150, 24 FPS and full HD format. And then at the color tab, this is the color management is set to OCIO and the config is set to ACES 1.2. So these are pretty much all the settings that we need in Nuke. And if I press R, I'll bring in the base PRT, so the main layer, and here it is. And we can start. We have a couple of layers here, but if we separate our combined volume and our visible lights, we'll rebuild our main beauty. So let's go ahead and start with a shuffle, and let's go to the node here. And for the label, in between brackets, I will type value in 1, and this will give me the name of the layer that I'm shuffling in. So first we'll start with the combined volume, and we can run a denoiser on both of these AOVs. So from here I'll just do a denoise, and we also want to use, we can see we have a motion input here, and we can drop down a vector generator, and I'll point this to the main beauty, the source, and this will now be our motion input in the denoiser. And I'll just increase the area here for our sampling, and really in this case I think we can place this wherever, because it's usually you have to place this wherever you have more noise in your scene, but since our noise is pretty much equal across our image, I think it's safe that we can just place this in any place, and we'll enable temporal processing, and we'll increase the frame blending here by quite a bit. And we can see how with this temporal processing we actually get some pretty good results, and I can also increase the luminance blend here to maybe 1. So we can see we have a pretty smooth result from a rather noisy render, and we can keep things as they are for now. I'll just drop down a gray node and maybe just gain this down slightly for now. We'll probably come back to this later. So this can be our fog layer, and from here we can bring in our visible light, so our actual particles. We can use a postage stamp, which is like an object merge in Houdini. With a postage stamp I can point to the same beauty render, and I can hide the input here for this node, so we don't see this connection when this node is unselected. And we can just copy this shuffle that we already set up with the expression. I'll press Alt-C and create a duplicate, and with this layer we can plug in our visible lights. And here we can start by running the same denoising operation that we have for our fog. So I'm just going to grab these two layers. Let's copy these and paste them down below. Again, I'll point the source for this vector generator to the beauty, and the source for the denoiser to our shuffle. And we can see, maybe for this, I'll just point over here. We can see that it really actually doesn't make much of a difference in this case either, where the sampling region is. And we can see that we do have a fairly decent result. I can increase the frames blending here if I want to further try to smooth things out. Now there's really only so much we can do to actually make this as smooth as possible. We would have to use maybe motion blur directly in Houdini and maybe even use more particles with a lower P scale. But after we do some grading, add some glows and blur, this will actually be a lot more smooth overall in our final result. But for now, we are good to go. So from here, we can use this layer to create a lot more details. So from here, we can simply merge this on top of our fog, and I'll set this operation to plus. And we can start working a little bit on these particles. So if I just look at the denoise result, the first thing that I would like to do is try to introduce a little bit more color variation. And this is also mainly to illustrate some cool things that we can do directly inside of Nuke. So we have a rest attribute, a rest position on our particles. And we can use this to map some noise onto our particles. So if I place down a node called P, let's go to noise advanced. So P noise advanced, and this is part of the Nuke survival toolkit. So make sure you have that installed. I can point this image to our render, and for the position data, let's maybe preview this result, and let's set this back to RGBA. So this is what we get. We get a noise pattern, but currently this is mapped to the RGBA data. So we can choose here, we can choose our rest, and now as I start to decrease the size, we can kind of see this noise pattern as it travels across our particles, which is really cool. So I can maybe decrease the octaves here to make this a little bit smoother. We can also decrease the linearity, and we can play around with the gain and the gamma, so we can hopefully see our noise better. But actually I would like to increase the size, so I would like to get these big splashes of black and white contrast. So I'll just increase the size of this pattern, and we can use now these black and white values to alter the color of our main render. So if from our denoise I do a hue shift, I can point the mask to our noise, and let's make sure that if I press A, we also have the alpha here, because by default the mask will look for the alpha. And now I can simply play around with the hue rotation. So if I were to decrease this, we can kind of see that based on where our white values are in our noise, we start to turn the color in our render from this pink color to blue. So this is what I would like to do, and we can turn this on and off so we can see this result, and we can further control this from our noise values here. If I were to increase the gain or play around with the gamma, we can kind of see the different results that we get. And one cool thing that we can do with this noise is we can also animate this and make our noise evolve. So if I increase the third value here, we can kind of see how our noise starts to travel, and we change the pattern over time. So we can just link this value to an expression, so we don't have to keyframe this. I'll press equals on this value to bring up the expression tab, and here we can do something like we'll use the frame number and we'll divide this by a high value here. Let's maybe try 75, and now we can probably preview the speed. Let's maybe just cache a few frames. All right, probably we can go a little bit faster. So if I go back to the expression, let's maybe divide this by 25, but probably this will be too fast, or maybe actually this works. So we can kind of see how our noise pattern changes over time, and this is to introduce even more variation to the color of our particles. So if I preview this from our hue shift, maybe zoom in on a few frames here and cache these, we should hopefully see, and this will be, I want this to be a rather subtle effect, but some of this blue color now changes over time. So we just have a little bit more variation, and this is just to give you more of an idea on some of the stuff that you can do with these custom attributes that we set up. So one other cool thing that we can do, let's maybe add another dot over here, drag these down. One other thing that we can do with the attributes that we set up, let's go to our beauty, and and we also have a distance attribute, which is this increasing value from the center of our particles. Let's go ahead and shuffle this out. So we can copy this shuffle that we have with the expression, and here we can just link this back to our render, maybe add another dot over here, and let's bring in our dist value. We can see that this is just a float value, so we can plug this in our alpha, and if I press A, we can preview this. And if I drop down a gray node and set this to only affect the alpha, I can increase the white point, and in this sense, the black point and the white point is sort of like a fit range node in Houdini, in VOPs. We can just spread this gradient by increasing the white point. So now, after this hue shift in our main render, I can place down another gray node, and I can point this to the dist layer over here, and with this grade I can set the gain to 0, and we can see that this will only now affect the parts of our gradient which are white. So if we go back to our mask, I can go back to the gradient here, and I can even play around with the offset if I want to kind of shift the entire gradient, but probably this is not what we want to do. But maybe I'll increase the white point so we don't really fade off too much of our particles. So we can do something like this, and also we can see that because our particles are denoised but our shuffled costume layers aren't, we get a little bit of this weird result. So maybe we can just smooth out this gradient if we drop down a blur after it, and we can just increase the size here. Let's increase this by quite a bit. We don't really need to be super precise here. We can see that now we have the same result that we had earlier on our particles, and our grading here with the mask is working just fine even with the blur. So this will be fine for now. Let's look at our final result, and probably we can grade down the fog even more. Let's do something like this, and maybe I would like to introduce more blue, so I'll add another gray node here, split the color wheel, and maybe just reduce the red and increase the blue, just so I shift this color a little bit more towards blue. So now with our main particle layer here, we can, let's drop down a gray node and just make this overall less bright. So I'll just drop down the gain, and with a separate layer I would like to introduce a little bit of white highlights. So this is something that I always like doing with particle layers. So I'll drop down another gray node, and I'll point this to our mask gray node over here. Let's make another dot so we can clearly see this chain, and with this gray node I'll just decrease the gamma by quite a bit, and this will give us super saturated colors. So I'll drop down the saturation, and I want to make this very close towards white, and with this layer now we can just place this on top. Let's set this to plus, and we can have this kind of like hardcore layer here in the center. But probably we can maybe expand the gamma a little bit more. We can do something like this, and maybe after the saturation we can drop down another gray node, and I don't really want this layer to be this strong, so maybe I'll just drop down the gain. We just want a little bit of whiteness in these particles. I think it provides a really cool contrast. And probably for our main layer we might want to bring up the intensity a little bit. So from here we can also create our glow pass. So we will use AP glow, and for this we will need to drop down a crop node, and we can point this, let's point this to our main particle layer. We'll drop this down below, and we can also use an AP glow node, and this is my favorite, exponential glow, and it's available with the new survival toolkit as well. So with this layer I want to crank up the contrast quite a bit, so let's decrease the source white, and let's do something like this, increase the persistence quite a bit. I want a wide spread on this glow, and we can decrease the intensity. So let's start with something like this, maybe decrease the response, and let's add this on top and see how this will look. So if we set this to plus, we have a pretty cool result. I think we can still play around more with this layer. Let's maybe do something like this, play around with the intensity, but I'm pretty happy with how this is starting to look, and we can already see a huge difference with just a few adjustments. We went from this to this, so a really big difference already. Let's do another dot over here and here, And I would like to also, we can start working on our Godrays layer. And for this, I would like to use this particle layer to sort of generate a new layer. And what I mean by this is we can point back, maybe we can actually point to our grade node over here after the hue shift. So if I do a postage stamp, I can point to this and I'll just drag this down. So we have, we just isolate this render at this state. So from here, what I can do is if I type here edge, we can use a edge detect. So this will look at the RGB values of our image and it will create an alpha mask for us where there is this change between colors and intensity. So if I press A, we can see this is what we get. Now this isn't really helpful by default, but we can kind of see some of these strings that are starting to create, and we can play around with the erode size to maybe get a better result, and maybe the blur size as well. So we can play with the erode size and the blur size to try to get a better result, and we can see that when I start to increase the blur size, this is giving us something that we can actually work with, but we can also blur the RGB values on our main image before we do our edge detect, and this should also help to smooth things out quite a bit. So a combination between all of these values will give us something that looks like this, and I want to use this image over our RGB image, so over this render that we have here. So I'll drag these to the side, and this edge detect is outputting an alpha for us. So from here I can do a K, and I want to copy the alpha channel to our main render. And now that our main render has this alpha channel, we can do a pre-mold. So it will use the alpha as a mask to cut out parts of our main render. So we end up with something like this. And in this way, we can sort of create new passes or layers directly inside of Nuke, which is really, really helpful. And we can, of course, combine this with other filters or with some of our other existing AOVs to create even more interesting details and layers. And this is what we do in a dedicated module in our latest workshop, Particle Effects in Houdini and Nuke. We have a module specifically dedicated to all of the cool things that you can do directly inside of Nuke to improve the particles. So if you're interested, check that out on voxsite.com. But for now, we can go back to our effect. So what we want to do with this layer is just use this to generate Godrays. So from our pre-mold, we can drop down a Godrays node. And here I'll place the center down below our particles center here. And I'll just increase the scale and we can see the effect that we get. I'll set this to color here. Let's set this to 0 and we can play around with the gamma. Maybe we can push out the rays a little bit. And for the steps, we can use a value of 10 here. This will give us a good result, and maybe I can increase the scale even more. And if I modify the center, we can see we offset the direction of our Godrays. And we can also drop down a crop node here to remove all of this information. We can see that if we don't have the crop node, this really expands the bounds of our comps. So this will add unnecessary overhead in our comp. So we can definitely use a crop node after. Now from here, we can just merge this on top and see what we get. We'll probably have to do some modifications, but I'll set this to plus and we can kind of see our Godrays layer. Now we can go back here and we can still add a gray node after, and maybe we can push out the gamma a little bit. Probably I want to grab the center and maybe try to offset this a little bit so it's more perpendicular to our particles. And maybe I'll decrease the scale in this case, decrease the gamma. And we can also go back right to our main render here. If I drop down a gray node, I can maybe push out the gamma a little bit. So now we can see we have more of our overall rays generating this Godray. We can maybe increase the gain here as well. Let's play around a little bit with this edge detect. Maybe we can increase the erode size. Probably this is too much. Another thing that we can do do actually is we can just drop down a gray node after the edge detect and set this to alpha, and we can play around with the gamma instead. So this will probably give us a little bit more control. If I decrease the white point, so I can just push the gamma down slightly, and let's see the result that we have. So pretty cool. Maybe I would like the first layer of particles over here with this gray node. Maybe we can just lower the gain on our main particles. All right, so now if if this layer is darker, we should see our Godrays a lot better. But now we probably have to offset our glow, and really probably this glow layer over here should point to our particles before we do this gray node. So I'll just reconnect this to our first gray node over here with the mask, and maybe just play around now. We can decrease the intensity. All right, so we can do something like this. Maybe let's decrease the source white. So this is all completely subjective. You will probably have a way different result if you're following along. But something like this should be fine. Another thing we can do with this Godrays node is also run a glow pass on this as well. So if we do another crop and an AP glow on this Godrays layer, we end up with something like this. So this can also be something really cool that you can do. Maybe increase the persistence, or maybe in this case we might want to use a lower persistence. So maybe actually I will use this result instead. So I'll just point the merge layer to the AP glow, and I think this might give us a better result. So I think we're good to go with the main layer for our particles, and let's introduce our second layer as well. I'll press R to bring in a new render, and I'll select this add PRT layer. Let's bring this in, and here I rendered this, if we go to the AOVs, I rendered this with the fog layer as well, but I didn't end up using this, so we don't have to worry about this. We just have our RGBA layer and this rand layer for the random value that we set per individual particles that goes from 0 to 1. And let's go back to the RGB layer. We can use another shuffle. Let's maybe just copy one of our shuffles with the expression. I'll grab this one, copy this down below, and let's link this up and separate our visible lights, and let's relink our RGB layers. So from here right away we can drop down a gray node, and let's lower the intensity by quite a bit, and let's also run a saturation node here and just decrease this, and we can merge this on top of our chain and see what we get. So not the best result right away. Now the first thing that I would like to do is randomize the intensity per individual particle, and this is why we have our rand costume layer. So I'll just duplicate the shuffle, point this back to our render. Let's maybe add another dot here, and let's bring in our rand layer, and this is another float values, so we can just place this in our alpha and we can preview this here. So after this saturation node over here, we can point the mask of another gray node to our random value. And if I were to, let's set this to all the way to 0, we can kind of see we get a result, we have something happening. And maybe to make this more noticeable, we can go to our random color over here. I'll drop down a gray node, set this to alpha, and let's preview the result. And I would like to crank up the contrast overall so we have a clear indication if this is working. So I can just lower the gamma and maybe lower the white point, and now we can see this white value here. We also want to do a white clamp so that these values don't go above 1, and let's just increase the contrast. So hopefully now in our main layer we should see this change more clearly. And what happens here, we are left with this kind of outline on our particles, so our mask isn't matching exactly. This is to do a little bit with anti-aliasing. So this rand custom layer, custom AOV that we set up is not entirely perfect, but we can kind of modify this a little bit. We can expand the edges a little bit with an erode node. So on our grade node here, we can drop down an erode, and we can just increase the size here to maybe 1 or 2 pixels. Let's try something like this. So if we go preview this from our gray node, we can see that we almost got this. Probably we can just increase this to a value of 2. So now we actually get the result that we want, and we can go back to our grade for the alpha, and we can play around with the gamma. Maybe we can increase this And we can see that as I play around with the white point and black point, we can start to introduce more variation in the intensity of our particles. So this is the result that we get. So this will be good for now. Let's from here add another node. And one more thing that I would like to do with this layer as well is just fade this towards the edges of our comp. Now we don't have a dist layer. We could have set this up as well, but really since this is more of the camera isn't really moving that much, we can just use a simple radial instead. So if we drop down a radial, I can just increase this mask here and we can see what this does. We will increase this and I will set the softness here to 0 and use a blur instead to fade this out. I just find that this is easier to control, so I'll just increase the size here for the blur and we'll drop down another gray node and point the mask to our radial, and let's set the gain here to 0 and click invert. So this is just one very simple way in which we can just fade off the edges here, and probably we can increase the blur value even more, something like 700, and still let's maybe just increase the radius a little bit. So something like this. Now it's starting to look slightly better, and let's go ahead and add some glow to this layer as well. We'll do another crop node and we'll use our AP glow. Let's go ahead and see what settings we should use here. Maybe decrease the response here, crank up the contrast a little bit, increase the persistence, and maybe decrease the intensity, maybe increase the persistence even more, spread out the radius of this glow by quite a bit. Let's do something like this, should be decent, and if we plug this back, we are starting to get a pretty cool result. And we can do the same thing that we did earlier with introducing a little bit of whiteness in our particles. If we do another gray node, maybe before our glow, we'll drop down a gray node, point this to our main render here, and with this layer we can just lower the gamma by quite a bit and maybe increase the gain and do a saturation node, and let's just set this to 0. And let's add this over our glow, maybe over here. So if I set this to plus, we can see that with this layer some of these particles will get this very nice whiteness. Again, this is sort of like adding this hot core in some of these particles. And if we preview the final result, we should see this here as well, this subtle whiteness inside in the center of our particles, which I think is really cool. And one final thing that we can add maybe for this add particle layer is we can play around with some glint. So if we drop down a glint, maybe we can point this to our render before the AP glow. Let's do something like this. And the glint, if we set this to effect only, we'll just create this kind of radial flare on our particles. Maybe we can increase the number of flare here. Let's do something like 5. And I also like to increase the odd ray length and maybe play around with the overall length, and we can kind of see what's happening here. We can probably reduce the tolerance so we can consider more particles. We can also play around with the rotation, and we can just add this on top of our, let's maybe just add this to our glow chain over here. So if we merge this, let's set this to plus, and let's preview the final result. Probably this is a little bit too much, so I can add another gray node after the glint, and I can just lower this value by quite a bit. We want something super subtle because we already have the glow on top. So we just want to add a little bit of extra detail on these particles. Now, this might be a little cheesy, but I think it works fairly well if you make it subtle enough. So this is why I would like to, lower the brightness of this glint. So I think from here we are good to go and we have everything we need. So one final thing, adjustments we can add is usually I like to add another gray node on top of everything and maybe just increase the contrast a little bit so I can decrease the gamma, increase the gain. We can do something like this. And this final grading adjustment has this sort of effect over the comp where all of the layers are just blending together more cohesively. And on that note, we can also diffuse the entire comp a little bit with just a simple blur node, and we can increase the size for this by quite a bit, and then we can just lower the mix value. So this will also help to smooth out everything. And again, it has this property of just merging all of the layers better together. So we can see that this is with this blurring diffusion, which in this case I think helps quite a lot. Let's add another crop node after this, and finally we can add a little bit of vignette around the edges. So there's a node in Survival Toolkit, AP Vignette, which we can also add, and we can play around with some of the settings here, maybe increase the aspect ratio, increase the fall off, decrease the amount by quite a bit. So this will also help draw the attention more towards the center of our comp. So really, this is everything that I did in the original comp. And with our comp finished, we have reached the end of this course. So I hope you enjoyed this. I hope this was helpful. And I hope this gave you a better idea on how to achieve certain effects without actually simulating anything. I hope this gave you some ideas that you can try in your own projects with using the polar coordinates and mapping the noise in this spherical kind of way. And also for our secondary layer, we've gone through another example of using the modulo function. So I will recommend watching the practical VOPS lesson using modulo if you haven't already. But for now, this was all that I wanted to cover, and hopefully we will see each other again in a new course.